Alright, if there's anybody out there in YouTube land that loves fractions, and you are going to love this lesson. It's a tough one. Tough one on fractions. So hopefully all of you can look at this, say 2/3 plus 3/4. I can do that. We know that we need to find a common denominator. The common denominator in this case is going to be between 3 and 4 would be 12. Hopefully you know that to change this 3 to a 12, we need to multiply it by 4. So we multiply it by 4 over 4 times our 2 over 3. We have plus 3 over 4, and to get this denominator, this 4, to a 12, we need to multiply it by 3. So we multiply it by 3 over 3. We're multiplying it by 4 over 4 or 3 over 3. I'm not changing the integrity at all of our problem because 4 over 4 is equal to 1, 3 over 3 is equal to 1. So I can simplify this to 4 times 2 is 8 over 12 plus 3 times 3 is 9 over 12. So this is the same thing as 8 plus 9 over 12, and 8 plus 9 is 17 over 12. We can't reduce that any farther. So this is as difficult as it's going to get today. Just finding a common denominator and adding or subtracting. The catch is we're going to have variables with that. So our goal is to get to something like this today. We'll start off a little easier though, right here. So here we have two fractions added together. We have a 3x and a 2 in the denominator. So we can do just like in this problem here. If we ever multiply our denominators together, we can find a common denominator. So 3x times 2 is 6x. So I'm going to make both of these a denominator of 6x. So to make this denominator 6x, hopefully you see that we just need to multiply it by 2. So I multiply that by 2 over 2. And over here, I need to multiply it by 3x over 3x. So 2 times 2 is 4. 3 times 3x is 6x. So I can simplify this down to 4 plus 6x all over 6x. Remember that the denominator always stays the same. Just like in the problem before, our common denominator was 12 and 12, and it stays the same at 12. We don't go adding that together, just what's on top. So I see that 2 is a common factor with everything in the numerator and denominator here. So I can factor out a 2 out of everything. So 2 times 2 plus 3x over 6x. I know that 2 over 6 is 1 over 3. So I can say, I cancel this out, and I cancel that out with a 3. So I say this is equal to 2 plus 3x. That's not a 3. Let's go ahead and write it over here. I'll go over here and say this is 2 plus 3x over 6x. And that would be the simplest form that I could put this answer in. Alright, let's look at some more of these finding common denominators. So here, this is a little bit more complicated. We have x squared minus 9 and x plus 3 as our denominators. So I could say my common denominator is x squared minus 9 times x plus 3 for both of my fractions here. Do that. But I think that there's something a little bit smaller. So when we do this, you can kind of think like if I had 1/3 plus 1/6. Our common denominator isn't going to be 18. It's not going to be 3 times 6. Our common denominator here, hopefully you can see, is going to be 6, because I can change this 3 to a 6 by multiplying by 2 over 2. Same idea here. So I'm going to factor my denominators. Whenever we have a squared term, always think factor, 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 factor forever and for the rest of your lives. Always think factor. So I'm going to rewrite this as x minus 2 over, that's a difference of squares, x plus 3 times x minus 3 minus x minus 4 over x plus 3. So you can see that we have, in this denominator we have an x plus 3, and this one we have an x plus 3 as well. So the only thing that I'm missing is x minus 3 in this one. So I can multiply this by x minus 3 over x minus 3 to get my common denominator. So then I'll get, let's see here, we have x minus 2 over x plus 3 times x minus 3 minus x minus 4 times x minus 3 over x plus 3 times x minus 3. So we have the same denominator now, so we can combine these two terms. So we get x minus 2 minus, we have this term, x minus 4 times x minus 3 all over x plus 3 times x minus 3. It's a lot of work. Alright, so the numerator doesn't quite look simplified. So what we're going to do is we're going to multiply out these values here. So I'm not going to touch my x minus 2 yet. So we have x minus 2 minus all that stuff inside there. If I multiply this out, I can use my square if I want to. X minus 4, x minus 3, that's x squared, blah, 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 blah. I can do it in my head. Hopefully you guys will too by the end of this chapter. X squared minus 7x plus 12 all over x plus 3 times x minus 3. Alright, so I need a little more room here. We have a negative, so we have x minus 7x. So that's going to give me a negative 8x. We have a negative 2 minus positive 12. Negative 2 minus positive 12 is going to give us a minus 14. And this negative we have to distribute to the x squared as well, so that's going to be negative x squared. Alright, so the next step, this is our numerator. If we separate out our numerator, then we should probably separate our denominator out as well. So they both look the same. So I can FOIL out my denominator here, x plus 3 times x minus 3. And I already know it's going to equal this, because it's the opposite of factoring. So it's going to equal x squared minus 9. So here is my answer. When I take this fraction and I subtract it from this fraction, here is my result. It's pretty complicated and ugly, I know. Alright, let's look at the last one. So here we have two fractions. They're looking pretty ugly. So whenever we see this squared and an x and something else, squared x something else, first thing we should be thinking about is factoring. So let's factor. So this is going to be x minus 2, x plus 1. If you want some extra help with factoring, come on in during lunch. I give you 100 factoring problems to work through. We can work through them together. I can give you some tips and tricks maybe. If you're not very good at factoring, it's a really good skill to have for SATs, for ICFES, for all that, for life. Factoring will help you. Alright, so here, after we factor it, we have x minus 2 and x minus 2 in common. And over here we have x plus 1 and x minus 1. So it looks like my left side is missing and x minus 1, because x plus 1 and x minus 1 are not the same. So I'm going to have to multiply this by an x minus 1, and the top by an x minus 1. And the right side is missing this x plus 1 here. We'll multiply it by an x plus 1 and an x plus 1. Alright, so if I do that, I'm going to go ahead and multiply this out. I'm going to distribute this out. And I'm going to get 2x squared minus 2x minus, so minus 4x. So it'll be minus 4x squared if I distribute that side. And a minus 4x. If I do 4x times x and negative 4x times 1, I'll get this. And this is all over my common denominator of x minus 1, x minus 2, x plus 1. Alright, it looks like we can simplify a couple things on top here. So I'm going to simplify 2x squared minus 4x squared is going to give me a negative 2x squared. And a negative 2x minus 4x is going to give me a negative 6x. And that is all over my x minus 1, x minus 2, and x plus 1. Long problems here, right? It looks like I'd factor the top a little bit. We can take out it's called the greatest common factor. The greatest common factor between negative 2 and negative 6 would be a negative 3. So let's do that. I'm going to pull a negative 3 out of the top here. And I'm not only going to pull out that, they both have an x in common as well. So I can pull out a negative 3x. And inside would go x minus, x plus 2. Negative 3x times x. Oh, that's not right. Didn't do that right. Let's see. Negative 2 and negative 6. The greatest common factor between them is negative 2. And they also have an x in common. So I could say this is x plus 3. We can double check by saying negative 2x times x is negative 2x squared. That works. And negative 2x times our 3 would give me negative 6x. That's right. Alright, so all this over our big long common denominator, x minus 2 times x plus 1. So I factored the top there to see if anything canceled out. Maybe we'd have x plus 3 in the denominator now, but we don't. So there's nothing else we can cancel out. So it looks like this is our final answer. Alright, practice that factoring, and we'll do some more in class. Have a good day.